Today we're going to be adding and subtracting polynomials. You need to know what polynomial is, and it's a monomial or the sum of monomials, meaning the addition of several monomials. A binomial is the sum of two monomials, and a trinomial is the sum of three of them. So let's do adding. So when we're adding polynomials, all that means is we're just adding the like terms. All right, now the book has you rewrite and group everything in like terms, and you either can do it vertical or horizontal. To me, it doesn't matter. Whatever's easiest for you. Like 2x squared. What would be like terms with 2x squared?
Negative 4x.
Negative 4x. I just go ahead and I label them first. 5x. What would be like terms with 5x?
6x.
6x. And then what would go with negative 7? So those are like terms, and you can rearrange it. If you've done enough, you don't even need to do that. But 2x squared minus 4x squared. You've got the 5x here that goes with the 6x, and then you've got negative 7 that goes with the 3. This is the vertical. The way they represent is vertical. But 2x squared minus 4x squared. What is that? Negative 2x squared. Make sure that the negative sign or the minus sign travels with it. Make sure if it's got a minus sign here that you make that negative. Okay, that it stays with it. You have to keep that. 5x plus 6x, what is it? 11x. And then negative 7 plus 3? Negative 4. All right. And you can do it a horizontal method as they write, and then just do 2x minus 4x and that. But it's going to give you the same answer as this. It's negative 2x squared plus 11x minus 4. Any questions? All right, let's do a couple more. Write this down. So I look for like terms. 3y goes with 4y. Negative 4y, you got y cubed. We'll go with 2y cubed. You got negative 5. We'll go with 8. And you got that guy by itself. So y cubed plus 2y cubed would be 3y cubed. And then the next one, like you're supposed to go in order of the degrees, which is just the power it's being raised to. So the next one would be 4y squared. Then 3y minus 4y is negative y. And the only thing left is negative 5 and positive 8, which would be 3. Alright, the next ones are going to be find the difference, find the subtraction. When we're finding the difference, right, we're going to subtract, but really what we're going to do is we're going to be adding its additive inverse, which the additive inverse is just the opposite of that. Alright, and the reason I say that is because everything in here has to be subtracted from its like term. So this would be subtracted from this, and this would be subtracted from this. Really, the easiest thing to do is just say that's negative 1, and you just distribute that out to every one of those. Okay, now, you don't have to write that. You don't have to show that when you do it. But I would rewrite this. When I rewrite it, okay, I change everything. I change the sign of everything in here. So this, instead of being 4x, it becomes minus 4x. The negative 5 is not negative 5 anymore. Now it's plus 5. And the 3x squared isn't plus 3x squared, it's minus 3x squared. Because the additive inverse is changing the sign of everything. So it's just making everything negative, or it's changing the sign. So if it's negative, it's positive, and it becomes negative. And then I'm just looking for like terms. So that with that, that with that, and that one with that one. So 2x squared minus 3x squared would give you negative x squared. If you write 1, that's fine, but the book's not going to do that. I'm not going to do that. But it's the exact same thing, so it doesn't matter. And then you have negative 2x minus 4x, so minus 6x. And then you have 3 plus 5 is 8. So there's your answer. Alright, first thing I'm going to do is I'm going to change the sign of everything on the right side. So negative, or 3p squared is now negative. The 2 is now negative, and the 9 is now positive. And then I just look for my like terms. Nothing else has p cubed. Nothing else is p squared either. So 4p cubed minus 3p squared plus 16p, and then negative 10. So there's my answer. All right, here's your assignment for today.